In today's lecture, we start a new article, first law of thermodynamics. The first law of thermodynamics is related to work and heat. So during expansion, piston moves through a finite distance. The gas does a positive work on the piston. So you can see here diagram. So when piston moves through finite distance, some work is done. So here internal energy decreases. Internal energy decreases when the piston is pushed in, so that volume of gas decreases. The gas molecule striking it gain momentum from piston. So they gain some momentum and gas does a negative work on piston. You can see a diagram here. So here the first diagram is positive done work done by system, and second one is negative work done by a system. System means the gas. System means gas. In first case, the piston is moving away, means gas expand. So the positive work done the on the piston or work done by the system. So it is a positive work done by system. And in second case, the gas is compressed. So negative work done by a system. So here internal energy increases in second case. Now you remember one thing here. When internal energy increases, when internal energy decreases. Consider a figure 4.7 which shows a system enclosed in a cylinder with movable, massless and frictionless piston so that its volume can change. You can see a diagram here, and this is a movable piston. Movable, massless and frictionless piston. So we consider here some parameters. Capital A is the cross-sectional area of cylinder. You can see this capital A. So that cross-sectional area is shown by blue lines. Rho, sorry, it is a P. P is constant pressure exerted by the system on the piston. P is a pressure. It is exerted by system on piston. You can see here the direction also it is shown in a diagram. You can see the direction. So this is the direction of pressure. So here F is equal to total force. F is total force exerted by the system on the piston. How we get this formula? F is equal to PA. You know that pressure is force per unit area. So by using that, force is equal to pressure into area. And that formula we use here. If the piston moves through an infinitely small distance dx, the work done by this force is, if piston moves with some distance dx, it is very small. Huh? The work done by this force is, you know that formula of the work done, the force into displacement, basic formula of the work done we use. Now force is pressure into area, cross-sectional area, and this is dx as it is. So we get work done is equal to pressure into cross-sectional area into this dx is the small distance. But here, this A into dx, A is the cross-sectional area, dx is a small distance through which a piston moves. It gives us volume. It gives us volume. Change in volume in short. It gives us change in volume. Hence, the work done by the system in bringing out this change in volume can be written as. So here, change in volume is occur. Now in that case, work done can be written as, you can see a formula of work done. So formula of work done is this P into dV. P is the pressure, dV is the change in volume. Now here, change in volume we can represent in term of initial and final volume. If Vi is initial volume and Vf final volume, the total work done in changing the volume of cylinder is, so this we can write by a formula, work done is equal to integration of this PdV. This is the total work done because we have to displace a piston from initial position to the final position. So in between these. So let me integrate this equation. After integration, integration of dV. So here you remember integration of dV is V. And here the limit is Vi and Vf. As we substitute the limit, we get Vf minus Vi. So this is the integration of dV. So that I directly written here. And this pressure part as it is because this pressure is constant. The change in volume in this case is very small because here we move the piston with very small distance dx, so change in volume is very small. When the amount of heat Q is added to system and the system does not do any work during the process, its internal energy increases by amount Q. On the other hand, when system does some work to increase its volume and no heat is added to it while expanding, the system loses energy to its surrounding and its internal energy decreases. So here two cases we consider. Okay, internal energy increases in first situation and on the other hand internal energy decreases when heat Q is added to the system and system does not do any work during the process. System does not do the work. So energy or heat added, this heat added is utilized for what? Is utilized to increase the internal energy. So here change in internal energy is written as a heat added. On the other hand, when system does some work to increase its volume. System is doing the work to increase its volume and no heat is added to it while expanding. System loses energy because system is doing some work. System is doing some work, so definitely it loses energy because whatever the energy system has, that energy is used to do the work and no energy is added, no heat is added here, and because of that system loses its energy to the surrounding and obviously the internal energy decreases. You remember these two cases because when we are writing the first law of thermodynamics, that time we must know what is here. This means that when work done is positive, this change in internal energy is negative and vice versa. When work done is positive, change in internal energy is negative. That you have to remember, and vice versa. Means if internal energy is positive, work done is negative. So we can write here. So change in internal energy is equal to minus of W. So in practice, the internal energy can change by both the ways. So internal energy can change by both the ways. Therefore, we consider the effect of both together. Now we consider both the effect together and we write the total change in the internal energy as. Now we consider both the effect and we write the change in internal energy formula. So this is the formula of the change in internal energy. So change in internal energy is Q minus W. Q is the heat supplied and W is the work done. Because whatever the heat supplied, if that heat supplied is utilized in doing the work, then this is a change in internal energy, Q minus W. Or this equation we can write in another way also. The same equation we can write like this way. Q is equal to delta U plus W. So in that way also we write. Q is what? Heat supplied. So what is the use of heat supplied? Whatever the heat supplied to the gas or system, it is utilized for two purposes. This is the first purpose and this is second purpose. Means to increase the internal energy or to change the internal energy. And second one is to do the work. And this is nothing but the first law of thermodynamics. This equation, let's see here. We have written this equation, delta U is equal to Q minus W. This is the mathematical statement for the first law of thermodynamics, which tells that change in internal energy. This is a mathematical statement and it tells that change in internal energy of system is the difference between heat supplied to the system and work done by the system on its surrounding. So this is a mathematical statement of first law of thermodynamics. We can rearrange and write. I told you here. The heat supplied we can write like this way. Delta U plus W. So this is also the first law of thermodynamics. So this equation 4 means that when amount of heat Q is added to system, its internal energy increases because heat added is used to increase this internal energy. This is the first part. Internal energy increased by amount delta U, and the remaining is lost in the form of work done. And the remaining is used to do the work on the surrounding. So this is a first law of thermodynamics. Now again we write the first law of thermodynamics. So it is the relation between heat and work. So let's see here the statement. If energy is supplied to system which is capable of doing work, then quantity of heat energy absorbed by system will be equal to sum of increase in internal energy of system and the external work done by it. It must be remembered that according to the accepted convention, sign means convention, Q is positive. You remember this when Q is positive. If heat supplied to the system, heat is supplied to the system, then Q is positive. And negative if heat is taken out of it. The second sign convention is work done is positive when work is done by the system and negative when work is done on the system. And the last one, internal energy is positive if temperature of the system increases, negative if temperature decreases. Now here, as for this first law of thermodynamics, the quantities W, Q can be positive, negative, zero. Therefore, this internal energy also positive or negative or zero. Now figure shows the case when more heat is added to the system. So you can see here, more heat is added to system than the work done by it. The internal energy of system increases. So you can see here how much heat is added, 200 joule. And how much work is done by the system, this is the 100 joule. So change in the internal energy is given by this formula, Q minus W, 200 minus 100. So 100 joule is change in the internal energy. And obviously the internal energy is positive here, so it means that internal energy increases. Now see the figure B. Figure B shows the case when more work is done by the system than the heat added to it. In this case, internal energy of system decreases. Now see here, heat added is 100 joule and system uses 200 joule to do the work. So the change in internal energy is Q minus W, means 100 minus 200. It is minus 100 joule. So change in internal energy is negative. So it means that internal energy decreases. If internal energy less than 0, you note one thing here, it means that internal energy of the system decreases. So system may be a gas container, huh? It may be a gas. So one more figure is there, figure C. You can see figure C. Figure C shows the case when heat added to the system and the work done by it are same. The internal energy of the system remains unchanged. You can see here heat added to the system is 200 joule and system uses 200 joule to do the work. Then change in internal energy is 0. 200 minus 200 is 0. So no change in internal energy. The law of conservation of energy is applicable to isolated system. Isolated system means system in which no exchange of energy as well as matter. The first law of thermodynamics, we already seen here equation 3, equation 4, is an extension of law of conservation of energy to system which are not isolated. That is, system can exchange energy. This exchange can be in the form of work or heat. Now next article is thermodynamic state variables. This is very important. We will use the term variable to describe characteristic of system. So when we are describing the system, that time we are using the variables. Variable means which are changing. For example, when we are considering gas, the pressure changes, volume changes, temperature changes, density changes, maybe a mass may change. Means these are variables. And these variables describe a system. These are measurable properties and are called microscopic variables of system. They are also called as microscopic variables. Now here variables are classified into two categories here. The first one is intensive variables and second one is extensive variables. Now what is intensive and what is extensive that we cover? Now intensive variable means do not depends on the size of the system. The variable which do not depends on size of the system, like temperature, pressure, density. So temperature does not depend on the size, how much gas is there, how much pressure is there. Okay? Means here pressure, temperature, they do not depend on the size. Extensive variable depends on size of the system, and it is mass, volume. You know that mass depends on the size of the system, as well as volume depends on the size of the system. So mass and volume are extensive variables.